Now we discuss about the types of access list. Basically, there are two types. The first one is standard. The second one is extended. Standard ACLs and ACL, extended ACLs. The standard ACL, these ACLs are used only the source IP address in an packet as the condition test. All decisions are made based on the source IP address. This means that standard access list basically permit or deny an entire suite of protocols. They don't distinguish between any of the many types of IP traffic like web, telnet, UDP and so on. But in extended list, it can evaluate many of the other fields in the layer 3 and layer 4 header of an IP packet. They can evaluate source and destination IP address, the protocol field in the network layer header, the port number at the transport layer header. This gives extended access list the ability to check or to make more perfect decision when controlling the traffics. The simply difference is that standard ACL checks only source IP addresses and it does not distinguish between telnet, SSH, web or any other services. It only checks the IP address, source IP address, but in extended ACLs it checks source IP as well as destination IP, and it also distinguishes between services that may be telnet, SSH, web, HTTP or any other. It means we cannot deny HTTP or SSH or web in by standard ACLs, but by extended ACLs we can deny HTTP service, web service, SSH, telnet, anything as we want. So it's better to use extended ACLs. There are another type of ACLs also available, that is named ACLs. In standard and extended ACLs we use numbers to identify the access list, but in named ACL we can use name or any word instead of numbers. Named ACLs have many other features that is very beneficial for us. We will discuss about the name ACLs after these two. Now the thing is we create a ACL on a router, but once you create an ACL or access list, it's not really going to do anything until you apply it. You need to apply ACL on any router interface, or you can say ACLs are inactive until you tell the router what to do with them. To use an ACL or access list as a packet filter, you need to apply it on an interface of a router where you want to traffic filter, and you have go to specific which direction of traffic you want the access list applied. When I'm telling about the direction of the traffic, then there are two terms that need to know. The first one is inbound ACL and the second one is outbound ACL. When an access list is applied to inbound packets on an interface, those packets are processed through the access list before being routed to the outbound interface. any packet that are denied won't be routed because they are discarded before the routing process is invoked. And the second one is outbound access list. When an access list is applied to outbound packets on an interface, packets are routed to the outbound interface and then processed through the access list before being queued. You can assign only one access list per interface, per protocol, or per direction. You can have only one inbound access list and one outbound access list per interface. The thing to notice before creating a ACL is anytime a new entry is added to the access list, it will be placed at the bottom of the list. For example, I am creating an ACL. This is my ACL rule number 1, or you can say the line number 1. This is line number 2. This is line number 3. Now at after some time or any time, if I am adding any rule or any line in this particular ACL, that line added at the bottom of the ACL, but before the implicit denied statement. If I am adding the another one, that added here. If I am adding another, then that added here. The implicit denied statement at the end always, but the new statement always added after the previous ones. And the next thing is, you can't remove one line from an access list. If you try to do this, or if you try to delete only one line, then you will remove the whole or entire list. The only exception is when you are using named access list. In named access list, you can delete only one line from the ACLs, but in standard and extended access list, you need to delete whole ACLs. You cannot delete only one line from the ACL. The next important thing about ACL is access lists are designed to filter traffic going through the router. They will not filter traffic that has originated by the router. For example, this is our scenario. There is a router, or you can say that there is a loopback. These routers are connected. This is a network. This router can filter packets by ACL that goes through the router. For example, here also a router. It generates some network. This network going through this router. This router can filter these packets, but this router cannot filter the packet that are generated or originated by itself. It means any router cannot filter packets that is generated by itself. Now take an example and explain the ACL. This is our R1, this is our R2, this is our R3. This router have a network, this also have a network, this also have a network. For example, this is network 1, this is network 2, this is network 3. If I am using standard list, so I can giving a command like this: deny network 1, allowed network 2. For example, I'm creating access list like this. I'm create 2 lines in this access list. It means there is a another implicit deny statement that says deny any other. if I'm applying this access list here on R1, it means R1 denies network 1. It means this network 1 cannot go through this R1. It means this network 1 cannot communicate with network 2 also, or cannot communicate with network 3 also. But what we want network 1 cannot communicate with network 3, but network 1 can communicate with network 2. But in this case, if we apply this ACL on R1, then network 1 also cannot communicate with network 2. So here I'm using this ACL on R3 instead of R1. If we are using R3, it means it denies the network 1's packets. It means network 1 can communicate with network 2 because ACL is applied on R3. If the packet goes to R3, then ACL applies. But on R1, R2, there are no ACLs. So network 1 and network 2 can communicate with each other. If network 1 wants to communicate with network 3, on this interface we applied the ACL, so the packet is denied here. So by this example we can say for standard list is better to apply ACL as closer as possible to the destination. Place IP standard access list as closer to the destination as possible. Because if we are using on source router or closer to the source router, then there is a chances then other networks or other communication may affect. So if we want to do not affect any other network or any other communication, so we need to apply standard ACLs as closer as possible to the destination. But in case of extended ACLs, we can apply these ACLs on destination routers also, on source router also, because in extended ACLs, the extended ACL says deny source network 1 and destination network 3. Extended ACL says or tell about source also and destination also, but standard ACLs tells about only the source. So we can apply extended ACL on destination also and on source also. If we are using on source router, then network 1 send a packet to communicate with network 2, then this ACL extended ACL checks by the router 1. Router 1 checks source network 1. It means this is network 1 that sees by this packet, and the destination network is network 3. But in the packet, the destination is network 2. So this packet is passed by this router or go through by this router. The only condition when the packet denies the source is network 1 and destination is network 3. So we can use extended list on destination also, on source also. But what is preferable or what is good to use? For this is R1, this is R2, this is R3. If you are using extended ACL on destination router, then packets generate here, it goes from R1, it goes to the R2, then it reach on R3, the packet is denied here. It means this packet consumes our bandwidth for this link and for this link. This packet consumes bandwidth for both links. But if you are using extended ACLs on source, then packet is denied here. It means we can reduce the consumption of bandwidth by that packet that is denied, that will denied on this interface. So it better to use extended ACLs on the source router. For standard ACLs, we need to apply standard ACLs on destination. For extended ACL, we need to apply, or we use extended ACLs on source routers. Now we check ACL or standard or extended ACLs one by one.